Hello and welcome again to Networks Learning, HSRP Configuration Part 2. So in this part, we will go through the hands-on configuration of HSRP. I'm using a CISCO Viral Lab. Topology is router 1, router 2. The LAN is on gigabit 01 for both routers. IP address on the LAN for router 1 is 10.1.1.10. For router 2 is the .20. The host is .25. I'm also using an internet router to validate the upstream traffic. The loopback address is 192.168.100.1. Router R1 will be active. We will use HSRP priority to set the active on router 1. And router R2 or RTR2 will be the standby. Some of the tasks that we will configure and validate in this lab will be to configure HSRP version 1 and then version 2, just to see some of the differences that were covered in part 1. We validate the status of HSRP as it is configured in a working condition, and then we will try to cause some failures and validate what happens and validate the failover when router 1 fails, and then when router 1 uplinks fail towards the internet router. We will use a feature called track-in, and we should see hopefully the results as expected. So let's go to our terminal and start the configuration. So I'll start by configuring my interfaces with IP addresses. So router 1 will have 10.1.1.10 and it's a /24. I'll do the same for router 2. The interfaces are both on shut or admin up at this point. No HSRP has been configured. So we'll start configuring HSRP. Remember, we need to add the virtual router or the standby IP address. I'll choose 10 as the group. And this will be my gateway IP address 10.1.1.1. To show the status of HSRP, the command show standby. Virtual IP address is 10.1.1. Active virtual MAC is unknown at this point. This is the MAC address that is associated with version 1. Now we got a syslog message. Standby is active. Let's run the show standby once more to see if there are any changes. Okay, the virtual IP is now set. MAC address is as it should be. Remember, 0A in hex is actually the group that we have configured for the standby, which is 10 in our case. The timers are 3 seconds and 10 seconds for the hold time. Priority by default is 100. So let's go and configure the same thing on router 2. Standby, same group, IP, and the same IP address because it's the same virtual gateway. It goes from active to speak because there's a negotiation taking place. Router 2 goes from standby to active. Router 1 is now standby because router 2 has taken or assumed the role of being active. Router 2 is active. Router 1 is standby. Now, what needs to happen if we want router 1 to become the active? So How about changing the priority of router 1? The default is 100, and the higher the priority, the better in this case. So on router 1, standby 10 priority, I'll set it to 150. And nothing will actually happen and nothing will change. There's another command that is needed, which is the preemption. So for stability, for HSRP to be stable, it's not because a priority of a standby router changes that the active has to relinquish its status and the standby becomes active. This is for HSRP to be stable. So to ensure that the priority affect the status straight away, we need to add another command, and that's the preemption. Standby 10 preempt. So when this command is implemented or is present, then anytime you change the priority or you make a change affecting the status of the HSRP router, it will actually take effect. So in this case, straight away router A had a high priority 150. He has assumed the role of being the primary or the active. I'll also add this command in router 2 on this side, just to be consistent and to have some sort of consistent behavior. Preempt. So now that HSRP is configured with the preemption and we have router A or router 1 as the active, router 2 as the standby, let's do one more check and start creating some outages. So router 1 is the active still. Router 2 is my standby. What happens if I shut the port gigabit 01, which is the LAN port? Let me just run an extended ping to the internet router and observe how many packets are actually lost in this process. So as you can see, we lost about 1 packet, which was the time for router 2 to assume the role of active after the failure was detected. We should be able to see that router 2 is now the active. The state for router 1 is in the initialization state because the interface is down, and that is the interface that is being configured for HSRP. So let us roll back. Because we have preemption configured, router 1 will go back to being active once more. Now, before we create the next failure, let's just take a look at our configuration once more. How about we configure HSRP version 2? For configuring HSRP version 2, let's just take a look at some of the differences between version 1 and version 2. So I'm on my interface gigabit 01 and I want to configure another HSRP group. So standby group, standby 0 to 255. So this is the maximum number of groups that I can configure when using version 1. So I move to version 2. And if I want to configure a new group, you can see that the range has extended to 4095 instead of 255. So let's stay with HSRP version 2 and configure router 2 with version 2 as well. The other thing that changes is my MAC address for the gateway, for the virtual gateway. Now that our HSRP is normalized again, router 1 is back to being active, router 2 is our standby. What happens if the uplink from router 1 to the internet router fails? Let's run our extended ping once more and shut gigabit 03 this time. There would be no connectivity because the host is still using router 1 as the gateway since it is deactive, but the uplink to the gateway is actually down, which means that the traffic to the internet router would be blackholed. So what we can do here is to use an HSRP configuration, which is tracking, whereby we will track the uplink. And if the uplink is down, the priority of that given router is decremented. So let's just open up that port, the uplink, once more. And configure tracking to start with. So track 5, interface gigabit 03, and is the line protocol that we want to track. So with this command we are simply tracking, we're not doing anything with HSRP yet. So under our interface, standby 10, still using the same group, track, and we will refer to track 5, which is our interface gigabit Ethernet 03, which is the uplink or the link to the internet router. So what we want to do here, we want to decrement the priority. We have 150 to start with. We had 150 to start with to ensure that router 1 is the primary. Router 2 is still running with priority 100, which is a default. So we want to go from 150 to anything that is less than 100. So we want to decrement, for example, let's say we decrement by 60. So what this means that if the interface gigabit 03 uplink, which is tracked, is down, the HSRP priority will go from 150 to 150 minus 60, which means it will be less than what router 2 has as a priority 100, and the priority will shift, or the active will shift to being router 2. So let's test this one very quickly. Let's first check our configuration is as it should be. So standby 10, track 5, decrement by 60, and we have our priority of 150. So we will end up with priority 90 for router 1. I'll run my extended ping and I'll shut the uplink. So straight away HSRP goes into a negotiation, and as you can see here, router 2 has become the active. We really have lost only one. I have to stop this extended ping. We've lost one packet. So let's check what is my priority. So even if we started with priority standby of 150, priority is now 90, which is 150 minus the 60 taken away by using the tracking command. Let's normalize once more. And reopen the uplink. So we are back once more to router 1 being the active and router 2 being the standby. So this is more or less the basic configuration line that you need, and most of the time you won't need more than this. In some situations, design-wise, you may want to have more than one group under one interface if you want to do load balancing. If you have several VLANs, for example, so you will have the odd VLANs part of group number 20 and the odd and the even VLANs part of another group 30, which means you'll be utilizing the bandwidth of router 1 and router 2 at the same time. But the failover will still be working and effective for both designs. So thank you for watching, and we hope to see you again for another session.